Another new exoplanet today, but this one is a first. It's the first exoplanet directly detected with JWST and a coronagraph on the MIRI instrument. Because of the bright starlight and because planets are dim and very close to their stars, at least from the perspective of observers on Earth, direct detection of exoplanets has so far proved very difficult. Enter the coronagraph, a device that blocks the light from a central star so astronomers can investigate the area around the star without the bright starlight overpowering everything else in the image. It effectively creates an eclipse of the star for the instrument. Our current theory of star and planet formation is that stars form from a rotating, collapsing cloud of gas and dust, and planets then form from a disk of material that surrounds the new star. The exact timing of this is not clear. We had always assumed the star formed first and then the planets later, but several new observations suggest that the star and planets actually form at almost the same time. In either case, it's much easier to try and find planets in disks of material that we are looking down on from the pole than systems we see edge on. Think about looking down on our solar system from above. It would be much easier to see the planets this way than if you were looking at the solar system edge on to the disk. The team that discovered the new planet used all this information to their advantage, focusing their search on young stars with planetary disks that were known to be oriented face on to us based on previous observations with other observatories like the Hubble Space Telescope. As you can see in this image of the star, JWST, there are 3 faint rings or gaps visible in the disk around the star, and astronomers assume that gaps like this indicate the presence of a planet. The difference here is that in the inner R1 ring, JWST has actually detected a source, and after a lot of checking and double-checking, the scientists have concluded the source is a planet roughly 30% the mass of Jupiter, orbiting about 52 astronomical units from the star. Relatively speaking, this is a very small planet to detect directly, and the researchers believe they can use this system to find planets with just 10% the mass of Jupiter in the future. Other, even more advanced coronagraphs are in development, and it'll be interesting to see how many more small exoplanets we'll be able to directly detect with those. The paper is published in the journal Nature Astronomy, and it is open access. I'll put a link in the description. That's today's video. I'll see you in the next one.